Welcome to the channel, guys. I'm new in all this YouTube stuff, so I hope you like what I created, and I hope you find some inspiration and useful information. If you would leave a like and maybe a subscription, I would be very happy. And this is what we are going to create today. Okay everyone, let's get started. Let's create a plane. Let's switch to cycles and create a little darker background. Just like that. Then we create a material that we call wave textures. Let's switch to the shading tab. Look at the whole thing from above. And add a wave texture, which is the base of all the calculations. Now set everything to rings and spherical. And there already is our wave texture that we can animate later with the face offset. Then we can use the texture coordinates, the object or the UV. Combine XYZ. So we can access X, Y and Z value manually. With the scale we can later adjust the frequency of the wave function. And the phase offset will animate the wave. Then let's create a mask node. And give the value minus frame because the phase offset is negative. So we use a driver for this. So the value of the driver changes with each frame, and with the second number we can multiply or divide that value so we can have a control over the speed of the animation. Push it all a little to the side. Now we have our setup for the wave and we simply put it in a group. Then we can duplicate it and access it later from different node groups. We can rename the output to output, or maybe better, we call it wave. And we set the whole thing to float value because we only want to export a black and white image. We can put the location of the X value into the input. And we can also put the scale and the phase offset into the input. So if we want to generate multiple waves, we can access them externally later. Let's tidy up a bit and rename the inputs so we can see from the outside what we want to input into the sockets. Let's call this one location. this one time, and this, let's call it frequency. So out of the group, and we name the whole thing wave, because it generates a wave. Now here we can see that with this location we can change the position of the center of the wave. With time we can animate it later. Or let's do it now maybe. With a mask node and minus frame divided by a value. I think I made a small mistake here. Maybe I confused time and frequency. Let's correct that quickly, like that. So we change the position of the inputs back to the top, and now change the input and set a frequency, so now it can change over time. And we have control over the speed via the second value. So since the wave group gives us a black and white image with values between 0 and 1, we can use a displacement node. A little tip, use a mask node for very small values with divide set to 1000, so you can have granular control over the value. And if we put the displacement output into the displacement input of the material output, we can see that we can't see anything. So we need some subdivisions first. Yeah, crank it up to the max. And now we can see that we still can see anything. So go to the material settings, displacement, displacement only, and voila, we have displacement only. Change the second value to a higher number, so we have a granular control. And it's also animated because of the frame driver. Now let's change the lighting settings a bit so it looks a little nicer while we're working on it. To get rid of all these jagged edges, simply set shading to smooth. We see that we currently have around 4000 faces, so we can still add some subdivisions. $16,000. $264,000. And 1 million. Okay, so it gets a bit laggy here. With subdivisions enabled, disabled, it gets really fast. So let's find the sweet spot. So let's leave it at 2 subdivisions. It runs quite smoothly. If we get higher, it starts to stutter. So next we will deal with the slit plane, and for that we create a cube and scale it down on the x-axis by 0.1 and again by 0.1, and now we have something that we can work with. Yeah, looking good to me. So as we can see, this essentially divides the wave into 2 areas, but we only have 1 wave. To split the whole thing into 2 areas, we will create new texture coordinates. and we use the generated or the UV output. Blah. So this time we make a separate XYZ and put the generated into it. And if we cycle through the values, we can see that we get outputs for each axis with values between 0 and 1. So if we create a color ramp, we can manipulate the value and manipulate it to our likings. When we set the value to constant and put it around 0.5, then we have a hard cut in the middle. So we can use this as a mask, and in combination with a mix node, we can use the black output for the first wave and the white output for the two other waves. For that we create 2 more waves of the group that we already generated, and we will change the location of those waves. Let's turn off the displacement so we can see it a little better. So if we set that to 0, we will have it in the center, and for the other one as well. We now have 2 overlapping waves, but we can see that we need to export another location so that we can change the Y location too. So we could create a new input value and set it to Y, or we could also undo that and just drag the Y location into the group input, so it creates min-max values automatically. Just rename it to Y location, and now we have access to it from the outside. So now we can also change the Y locations independently. If we multiply those 2 outputs, we can see overlapping waves. Put the frame driver into the time slot, and now we have it animated. But we want the 2 waves appear only on the right side. And for that we create a new mix node and put the output of the mask that we created in the factor, so that we have the upper output on the left and the lower output on the right. And so we already created our very first simple interference pattern. But we still have a lot to do. So next we want to create those slits inside the slit plane. For that we want to duplicate the slit plane and press Alt S to reset the scale, and roughly scale it to a size that fits to a slit. Should be a little larger than the slit plane, so we can use it as a boolean to cut a hole into the plane. Yeah, something like that. Looks good to me. Now let's apply the scale, because we will work with it again later. Let's add a mirror modifier to it, so we have 2 of those slits. Well, it's not mirroring at all. So let's create an empty axis, scale it down, apply the scale. And we use this for an object to mirror the slits. Let's rename some of our stuff. We call this mirror slits. This one is the slit plane. And this one is the slit, or the slit boolean. And this one, these are the waves. So now select the slit boolean and under mirror modifier, mirror output, select the mirror slits, and now we can see that it's mirrored. Amazing. Amazing. If we now position them on the y-axis at the position of the waves, they correlate. But if we change one of the positions of the wave, the boolean of course will stay in place. So first let's create the boolean. Select the slits, select the plane, press Ctrl and minus, and now we have our boolean. Let's tidy up a bit and put everything into the scene collection. Oh, not that one, like that. Beautiful. So when we now change the location of the wave, I remove the displacement so we can see it better. So if we change the location of the wave, the slit of course stays in place. But we can solve this by creating a driver that changes the slit position depending on the wave position. So what we need to do at first is to change it so that if I change the position of a wave, the other wave will change its position too. To achieve this, we create 2 new math nodes, one for granular control and one that multiplies with -1. Drag the multiply into the one slot and the divide into the other. So we have the same values, but one is negative and one is positive. And now they change both at the same time if we change the value. Awesome. If we now select the slit boolean and look at item and position, we see that it's set to 4 centimeters, and we can see that when we change the value, it changes the position. Now we simply go to the value we created here and right click and select copy as new driver. So now go back to the slit boolean, under Y position, right click paste driver, and we see it's now set to 4000 centimeters. To change it, right click edit driver, set the type to scripted expression and divide the value by 1000. And voila, it's back to its position. And furthermore, now we can control the position of the slits with the value we created, and it corresponds with the waves. Pretty awesome, right? So next we will have a look how we can expand the slit width, and we look at the scale value of the slits, especially the Y scale. So we will use the same principle here by just copying the mask node, reset the first value to 1, right click, copy as new driver, select the slit boolean, choose the Y scale, right click, paste driver. And now we can see we can control the slit sizes via this value that we just created. So maybe we should just start to give all the values names so we can have a better overlook at what we're doing here. So we call this one slit size, and this is a slit position. If we now set the frequency here, if we display both, we see that the frequency can be adjusted independently. For that we need a new value that controls all the frequencies. All the frequencies! So we name the thing frequency and drag it into every frequency input of the wave groups. Let's tidy up. Ooh, I like it clean and tidy. So now we can use this value to change the frequency, make it higher or smaller. And there we see an initial interference pattern of which we can change the position of the slits. But of course we don't have any control over the slit sizes yet. So now I show to you what it looks like on a 2D plane. You can see that the width of the slit doesn't change the wave pattern. This is because there's only one wave generator in each slit. If we change it to 2 slits, we can see a first interference pattern. That's what we have in the Blender file right now. But if we change the number of wave generators in each slit, we can see the typical expected interference pattern form. So this is simply an approximation. It was developed by Huygens and later refined by Fresnel. It says that at each slit there are multiple wavefronts that interfere with each other, creating this diffraction pattern. So we create this right here, right now. And what we need for that is multiple wave generators per slit and slit size, and we create a group with it. Oh, wait a minute. Let's undo that. We'll just take let's do it here. We first set the slit size a little bit larger so we can have a better overlook. Let's duplicate a wave generator. Tidy up a little so we can see better. Okay, we put this down here and put the time into it and display the one wave. So we need multiple waves. Let's duplicate it. What have I done? What have I done? Duplicate. Control Shift D duplicates a node group with all its inputs still connected. Just a tip. So let's multiply them so we can show two waves, and duplicate another wave generator and multiply it again. So we have three overlapping wave generators stacked on top of each other. We can now manually move all the waves, as you can see. But we want them to move depending on the size of the slits. I add another ramp here to see a little better what is happening right now. Like that. We look at it from the top and now we can see the three waves. Awesome. So now we need the slit position and put it directly in the first one. So now it's centered and that's how it should be. So the second and third one are basically in the slit position, added or subtracted with the slit size. So now we can set it manually, slit position plus manual value, like that. So now we will add the slit size to it, but the values aren't quite correct, so we will have to adjust it manually. It's because of applied scale and such. So we correct it manually. So this works, but of course we want to have it procedurally, so we can't use add, we have to use multiply. So now we have the positive value for the one, and we duplicate it and subtract it from the other. And when we display both, we can see that there are two waves, one at the beginning, one at the end. And here are all three together. Alright, and here you can see that it also works procedurally. When we change the slit size, the position of the waves also changes. Nice. So let's create two more waves. So we have 5 waves for each slit. So let's duplicate those 2 waves that we created. So now we need another multiplier and set it to the half of the first multiplier, so they will appear between the already created waves. So here you see the wave 1 and wave 2. Then multiply all those values again. Just serially connect them. And now we have 5 procedurally generated waves in each slit, or in the first slit. Now you can see that the wave function already changes and that the extreme values are more defined. Let's put it all into the displacement and have a look. And now we can see the wave created by interference. or rather diffraction. So interference is then created with two slits. So let's put it all in a group and tidy up a bit. Yeah, not much to tidy up, so let's leave it like that, I guess. Just rename those two to multipliers. Yeah, I think that's enough for now. But we still need the frequency. It's not connected right now, so we have to put it in each input of each wave generator. Just like that. I see that we have two output values, so just go into the group and delete one of those. And the other one we call waves. So now get back and delete those two wave generators that we don't need anymore, because we want to replace them with the new wave generators. So this is the upper wave, the initial wave, so to say. Yeah, let's call this one time. Why don't we see anything? Oh, it's not connected. So let's duplicate it, put one in the upper and the other one in the lower part, set one of the inputs to minus, and now we can see the interference pattern. We have both wave patterns in both slits, so in each slit 5 waves. Now we can displace it and we see the displacement. We can now adjust the slit size, the frequency, and the slit position. And it all changes procedurally. Beautiful, isn't it? So now we can see from the side view that all the stuff isn't quite level right now. This is partly because the mid-level of the displacement is set to 0.5. But we want it to be 0, because we want it to be positive and negative. And 0 should be the base value. If we now go into the wave and subtract 0.5 from the output, then we have negative and positive values. Alright. Now we immediately see that we hardly see anything in the output. But here you can clearly see the wave going up and down. To amplify the whole thing a bit, we will just create an amplifier. So we want to amplify the two output waves, and to do that we create a new mask node and set it to power, so we have better control over the amplitude that we create. Let's bring this down to get a clearer picture. This is the input, the upper part. And this is the output. So let's all move it a little to the left to have a little more space. Like that. Now let's create a new mask node and set it to multiply and put the output of the amplifier into the second value. And when we change the value here, we can see the beautiful diffraction and interference pattern forming. So now we can control the amplitude, amplification, split size, split distance and frequency. And of course the time if we want to, so the animation speed. If we now look from the side, we can see that we have positive and negative values, and in between the cancellation created through the interference of those waves. If we only want to show positive values, we can create a new mask node, set it to absolute, and all negative values are converted to positive values. Because you don't see negative light, you know. And this is how we create a beautiful interference pattern. We can also adjust the colors a bit by creating another ramp and put the output into it and change the colors of this. So maybe to green, and now we can put the output of this into the base color. And let's set this to red. You can adjust it later to your likings. If you turn off the absolute value by pressing M while selecting the node, you can turn off the positive values, and you can turn it back on to see it again. You could also put the absolute value after the output of all waves, and so the input wave will also be positive. Next I will show you how to only show the end of the waves from the output. So let's duplicate this color ramp. Move it all to the side to get more space. And let's create a new mask node, multiply, and set the second input to the color ramp. With this ramp we can determine where the waves should take place and where not. So we want to see the input wave, so set this one to 0.5. It's exactly in the middle now. And the final value we can set quite high. So the higher, the more of the waves will be cut. Maybe 0.999. Yeah, that looks good. But we can also set the material separately. So we put this to black and reduce the reflection, the roughness, so we can see a beautiful reflection, and this looks really nice. Pretty cool, right? So we're now in the original file I created. Here I added some more controls and a little more color spaces. So we have a look at that. Here is the option to adjust the slide distance. Here's the slide size. I can switch between one slit and two slits that generate waves. Here I can change the amplitude of the entire thing. And I can change the absolute values. And I can switch off the geometry, so you can only see the end waves. So the displacement switch off. And of course turn the entire displacement on and off if I want to visualize from top. And here are the different colors I tried out. This one's for the thumbnail. This is for testing to see where the color is flat. The standard value. And here with the red and green. It works really well with non-absolute values. So if you like what you see, please like and subscribe. I'm new to YouTube here, and I hope to find some people who find interest in the same things that I like. If you have any suggestions, please let me know. I'm eager to iterate.